Okay, guys. So here are the homework problems, and I just want to say that I don't want these homework problems to scare you. I wanted you guys to see some kinematic equations and get used to them, but the whole time in physics isn't going to be this intense with math and algebra. So uh, we're just going to get an experience of this. So I'm going to walk you through this. I'm going to set up all the equations, but I'm not going to solve. So the important thing is I just wanted you guys to see how to set them up. Okay, so 23. Uh, Here are my givens. I'm given acceleration, velocity initial, and final velocity. And this is a little tricky because they give it in miles per hour, so I have to convert. Um, so then I'm using my equation acceleration is equal to delta v over t. And then I can rearrange this equation and solve for t. All right, if I go kind of fast, you guys can just pause the video and write things down. Okay, the next question, 24, they give you a graph and it's asking for the acceleration at different times. So if I have a v versus t graph, the slope is the acceleration. So right here, the slope is 0. So for the first 0 to 5, the slope is 0, so acceleration 0. For the next section, I'm doing my change in velocity over time. Well, my change in velocity is my v final minus my v initial. So I got 8 minus a negative 8. And my delta t is 10 seconds. So I can solve that, and that would give me my answer for my acceleration there. And from 0 to 20 seconds, I'm doing my delta v is 8 minus a negative 8, but now I have a total of 20 seconds. So instead of dividing by 10, I'm dividing by 20. Okay, so part 2 asks for instantaneous velocity. So instantaneous velocity is the slope at any one point. So from at 2 seconds right here, the slope is 0. And you can think of the tangent line. So if you were to draw the slope right at that point, then the slope is 0. And if you come over here at 10 seconds, now the slope, I can solve that, and it ends up being the same thing as b over here. I take my slope would be my rise, which I rise 16, over my run, which I run 10, and that would give me my acceleration there. And then from 15 to, or at 18 seconds right here, the slope is again 0. All right, now 26. This is a hard problem, so I'll tell you guys what, if you actually graph this out, I'll give you an extra credit point, so that'll help you out a bit. But I'm just gonna briefly show what's going on visually, and if you graph it out, then I'll give you some extra credit. So graphically, it means that like actually on graph paper, graphing it out and seeing what distance the two equations cross. So let's look at this. So we got x of the car. So we have a car chase where we have a car and a trooper chasing that car, and the trooper has an acceleration. So if you look at the problem, it gives you the two equations. So it gives you this equation, and up above I show you how they got this equation. We have, since it's a constant velocity, you can just use this constant velocity equation where v is equal to the change in my displacement over time. And I rearrange for delta x. Well, delta x is just v times t. Delta x is x minus x0. And then I throw this x0 on this side, and they come up with this equation and you notice that it's just a linear line. In the trooper one, you can look through the derivation of this equation on the example problem, but we get a quadratic. So this quadratic means whenever you have a position versus time graph and it's curved like this, we have that it's accelerating. And I kind of have a mistake. It will never be vertical, like a parabola never goes vertical, so it would probably look more like that. So if you, the problem shows that the time is 16.9, and it doesn't solve for the distance, but graphically you could go through and graph this out and find out what the time or the distance is. So yeah, if you do that, I'll give you extra credit. Okay, 28, if we set this one up, we have Jules Verne sending men to the moon by firing a space capsule, and it says that there's a ridiculous acceleration, so we can try solving for that. So it's a 220 meter long cannon, and it's accelerating you, which we're trying to find the acceleration, to 10.97 kilometers a second. Now think about that. Like, a kilometer is a big distance over, or for 1 second. So if I do the conversion here, I get 10 to the fourth, roughly 10 to the fourth meters a second. So that's a huge velocity. Now we're starting from rest. So this is the kinematic equation that I'm using, and I just have to rearrange this for A. And I'll let you guys look at this and see how the algebra works out to find A. If you're stuck on algebra, don't get too frustrated. I can help you out with it, but again, the AP Physics 1 is not very algebra based. For the few of you that are planning on taking APC, it is really algebra based, so I wanted to give you guys or show you what this looks like. But again, don't get too frustrated with the algebra. Alright, let's look at number 29. So 29 is pretty straightforward. Oh, well, 29, there's actually something that's tricky. And that's I gave you guys, and on the formula sheet, there's only 3 kinematic equations. But there's really a 4th kinematic equation, which takes the average velocity here. And so if you're working on these problems, you probably got stuck on this one. But here's a little learning, teachable moment where this is another kinematic equation that you can use that uses the fact that you can find the average velocity by adding your starting and your ending point, dividing by 2. Like, you can think of, oh yeah, this is how you take an average. Alright, so I have my givens, and I'm looking for, in the first part, I'm looking for V0. So I can just rearrange algebraically and solve for V0. And once I have V0, then I can come down here, and again, you guys might want to pause this video and see how I algebraically solve for V0, and then I plug that in, and I use my acceleration as my change in velocity over time. This is the basic equation, like acceleration is equal to change in velocity over time. It's like how much you're changing your your speed, but with direction over your time. Alright, so 31. 31 is another just, I think, pretty straightforward one. You have all these givens, and you're asked to solve for your acceleration for A, and then your time for B. And for B, you get to choose. There's a couple different equations you can use. But for A, I'm going to pick the equation that doesn't have time in it, because for this first part, we don't know the time. And I rearrange the equation algebraically. And again, don't get too stuck. If you're frustrated with this, I can walk you through it. But for the homework, I want you guys to write it down. And then if you get stuck, we can work it out together. Alright, so I find A. And then once I have A, I can pick from any one of the kinematic equations because I have all my variables. But I'm going to pick the easiest one and solve for T. Alright, so I know I'm going fast, but you guys can just pause the video and you can write the problems down. I do want you to try solving these on your own instead of just watching this video to solve them all. But I don't, again, like I just wanted to lay this out and show you how the kinematic equations solve for unknown variables. Alright, so in this question we have a car, it's accelerating, it's starting at 24 meters a second, it's accelerating for 2.95 seconds, and it's asking for what's the car's acceleration. So bam, I'm going to use this equation here, solve for the acceleration. Then once I have that, B says, well, if you have that acceleration, how long does it take for you to go from 10 to 20 meters a second? So I'm going to use the same kinematic equation, but now my V is 20, my V0 is 10, my acceleration is whatever I found it to be up here. And the last question for C, it says, will doubling the time always double the change in speed? And the answer to that is yes, because for constant A, if A is constant, then the slope of this line is always going to be constant, because if we had the acceleration was changing, then we wouldn't be able to use these kinematic equations. So this says if you double t, will you double your speed? And that is a yes. If you double t, you always double v. And you might want to take a second to think about that, because this is an interesting question. And this part C, this is something that you might see on the AP1 physics test. Alright, I hope this helps, and yeah, I will see you guys on Monday.